So now let us discuss with the third method of preparation of aldehydes and ketones by a heading called as ozonolysis of alkenes. So here when it comes to ozonolysis of alkenes, alkene is dissolved. So here one should know that alkene is dissolved in carbon tetrachloride or it is dissolved in chloroform. So when the reaction is set to start, the alkene which is involved in a reaction is dissolved in either carbon tetrachloride or chloroform, and it is made to react with what? Ozone, because heading itself tells it is an ozonolysis reaction. So alkene dissolved in carbon tetrachloride or chloroform, when it is made to react with ozone, it gives an addition product called as ozonoid. And this ozonoid further heating with zinc metal, and upon subjecting to hydrolysis, it will yield aldehyde or ketone as a major product. This reaction is known as ozonolysis reaction. Now let us discuss the ozonolysis reaction to prepare both aldehyde as well as ketone. So let us consider an example. So this is an symmetrical alkene where I have taken a mono-substituted alkene. So now a question comes, why it is called as mono-substituted? Suppose if I have taken it as CH2 double bond CH2, then the name of this particular compound will be what? It should be ethene, but one of the hydrogen has been substituted in first carbon as well as in second carbon. So due to that reason we call this as a mono-substituted alkene. So when this mono-substituted alkene is made to react with ozone, remember alkene is dissolved in a medium of carbon tetrachloride or chloroform. So when this mono-substituted alkene is made to react with ozone, it should form an addition product called as ozonoid. Please remember, when we write an ozonoid, the oxygen atoms will be present at the extreme terminal ends, and here the bond breaks symmetrically between the two carbon atoms such that one carbon atom will be binded with one hydrogen and one alkyl. I write as one hydrogen and one alkyl, and the other carbon is also binded with one hydrogen and one alkyl. So this is called as an addition complex which is known as ozonoid. And the ozonoid which is formed, it undergoes C cleavage. Why it is mentioned as C cleavage means it breaks in the form of C shape. Hence it is called as C cleavage. And this C cleavage is possible when it is heated with zinc and upon subjecting this to hydrolysis. So when it breaks up into C cleavage, it forms RCHO. This is one RCHO. This is another RCHO. Hence, we get two molecules of an aldehyde. Now a question arises. So it is left out with one more oxygen. So this oxygen is taken away by what? Zinc metal to form ZNO as a byproduct. And this is the method by which we can tell that aldehydes can be prepared by ozonolysis of alkenes. Now let us discuss a reaction in which ketones are prepared by the same ozonolysis reaction. Now let us discuss a reaction for the preparation of ketones. So for this, here also we are going to consider an alkene, but this is called as what? Di-substituted alkene. Now a question comes, why it is called as di-substituted alkene? Because when we consider this alkene, both the hydrogens are substituted by alkyl groups. So hence we call it as an di-substituted alkene. So when this di-substituted alkene is made to react with ozone, again we are going to get what? Ozonoid. So while writing ozonoid, you should know that the oxygen atoms will be present at the terminal ends. So I have written the oxygen atoms at the terminal ends. So here the bond breaks exactly at the center between carbon-carbon double bond, so that one carbon is linked with two alkyl groups and the other carbon is also linked with two alkyl groups. So this is called as what? Ozonoid. So this ozonoid undergoes a cleavage called as an C cleavage, such that when it is heated with zinc metal, upon subjecting it to hydrolysis, so what we get? RCOR, and here also RCOR, so that we get 2 moles of ketone, that is RC double bond OR, along with the formation of zinc oxide. So this is the method. When a di-substituted alkene is utilized, we can get ketone as the major product, but when mono-substituted alkene is utilized, we get aldehyde as the major product. So this is the method by which both aldehydes and ketones can be prepared. So after discussing with ozonolysis of alkenes, let us discuss one more reaction which is called as hydration of alkynes, by which both aldehydes and ketones can be prepared. So when we study with hydration of alkynes, the reaction tells that when alkynes is subjected to hydration, means adding up of water in the presence of mercuric sulfate, that is HgSO4, as well as dilute sulfuric acid, by maintaining a temperature of 65 degrees Celsius, and further it undergoes rearrangement to give aldehyde or ketone as a major product. This particular reaction is said to be as hydration of alkynes. So after knowing this main concept, so the main theme of the reaction tells that alkynes upon hydration in the presence of mercuric sulfate with dilute sulfuric acid, by maintaining a temperature of 65 degrees Celsius, a particular product is obtained, which again rearrangement gives aldehyde as well as ketone. Now let us discuss how particularly this reaction can be written by considering an alkyne. For example, if I take CH triple bond CH. So CH triple bond CH indicates that it is what? It is ethyne. So when ethyne is added with water by maintaining mercuric sulfate in the presence of dilute sulfuric acid at a temperature of 65 degrees Celsius, so this water molecule will ionize as H plus as well as OH minus. So this respective OH minus will attack any one particular carbon. So since it is symmetrical, either it can attack this carbon or this carbon. So when OH binds to carbon, one of the pi electron shifts on what? Carbon. So that carbon becomes negative. Negatively charged carbon will take away H plus ion. So that I can write the intermediate as what? C single bond H with OH with double bond C H along with H. So this will be the intermediate that is obtained during the course of a chemical reaction. So this particular intermediate which is obtained, this intermediate undergoes rearrangement reaction. So when it undergoes rearrangement reaction, here how the rearrangement takes place, let us discuss. So this hydrogen gets eliminated as a proton, so that there exists a negative charge on oxygen. So this particular negative charge shifts between carbon as well as oxygen, where carbon and oxygen will get a double bond, such that this carbon will become pentavalent. To satisfy tetravalency, this pi electron will shift here, so that the carbon will get a negative charge, and this negatively charged carbon will acquire this proton, such that the major product will be what? CH3CHO, which is called as acetaldehyde. Hence, acetaldehyde will be the major product, which can also be called as ethanol, that is obtained when ethyne is subjected to hydrolysis reaction.